Good day, everybody. How are you all doing? Today, we are going to talk about how to conduct hypothesis test for proportions. So here I go. Hypothesis test for population proportion. So these are our objectives. Test a hypothesis about a proportion using the p-value method. Here, P stands for probability value method. Can virtual reality be used to enhance education? In a recent survey of teachers conducted by Samsung, 85% of them stated that using virtual reality in the classroom would have a positive effect. One specialist believes that the percentage has now increased to more than 90% since virtual reality equipment has become more available. She samples 500 teachers and finds that 471 of them believe that virtual reality would have a positive effect. Can she conclude that the proportion of teachers who believe that virtual reality would have a positive effect is greater than 90%? This is an example of a problem that calls for a hypothesis test about a population proportion. We use the following notation, that is symbols. P is the population proportion of individuals who are in a specified category. Sometimes the specified category is called success. So P is the population proportion of success. X is the number of individuals in the sample who are in the specified category. So X is the number of individuals, it's in the sample who are in the specified category. X is sometimes also called number of successes. N is the sample size, and P with the thing at the top is called P hat, is the sample proportion of individuals who are in the specified category given by P hat. And P hat is X over N, sometimes also called number of successes divided by sample size. So N is the sample size, it's in the denominator. X is the number of successes or number of peoples in that sample who belong to that specified category, which we are calling success. The method for performing a hypothesis test about a population proportion requires that sampling distribution be approximately normal. Remember, sampling distribution is the probability distribution of p hat, where we have p hat on the horizontal axis and relative frequency or probability on the vertical axis. We get a bell-shaped curve of probability distribution of p hat, which is called the sampling distribution. The center where the peak of the probability distribution or sampling distribution appears on the horizontal axis is given the center of this probability distribution, mu p hat, and that is equal to population proportion. The following assumptions ensure this. We have a simple random sample. The population is at least 20 times as large as the sample. The items in the population are divided into two categories, success and failure. The values of np0 and n times 1 minus p0 are both at least 10. Now you might be asking, we already know n is the sample. So what is p0? P0 is the value in the null hypothesis. So what they're saying here in number 4 is n times p0, or the number of successes, assuming p0 in the null hypothesis to be true. N times p0 is the number of successes in the sample, and n times 1 minus p0 is number of failure in the sample of size n. Both of them should be greater equal to 10. At least 10 means minimum is 10. It can be greater than 10. The test statistic is given by, remember, test statistic is a characteristic of the sample, which in this case is given by z. And just like any other calculation of z, which is the standard normal variable, is how far the sample statistic p hat in this case is located away from the value in the null hypothesis. Hence, in the numerator, we have the deviation or difference of p hat from p0, and that is divided by the sampling distribution of p hat, by the standard deviation of the sampling distribution of p hat, sometimes called standard error. So what do we have in the denominator? We have under square root p0, assuming null hypothesis to be true, that is the value in the null hypothesis, times 1 minus p0 divided by n, everything under the square root. The whole thing under the square root is the standard deviation of the sampling distribution of p hat, sometimes called standard error. So basically, z tells us how many standard deviation away from p0 is p hat located. If p hat is greater than p0, we'll get a positive value of z. How many standard deviation above the hypothesized value of p0? If z is negative, how many standard deviations below the hypothesized value of p0? Z is negative. So for the negative z, we have a left tail test. So what is the p value? The p-value in the case of a left tail test when p hat is less than p0 is the area under the standard normal curve or z curve for p hat to be for z to be as extreme as what we have calculated, at least as extreme as what we have calculated. So for a left tail test, so p hat is less than p0, the area of the rejection of null hypothesis in the null hypothesis, in the area of rejection of the null hypothesis under the standard normal curve, total area of rejection is equal to level of significance, and the p-value is the area to the left of the test statistic. That is, it signifies what is the probability of getting a test statistic at least as extreme as what we have obtained. Okay. So the area depends on the type of the test. So for a left tail test, p value is the area to the left of the test statistic under the standard normal curve. For a right tail test, which means alternate is greater than area, p-value is the area under the standard normal curve to the right of the test statistic. In this case, p hat is greater than p0. And for a two-tailed test, we multiply the p-value by twice the area. Okay. An educational specialist in studying the attitude of teachers about the use of virtual reality in the classroom. She samples 500 teachers, that means n equal to 500, and finds that 471 of them believe that the virtual reality would have a positive effect. So X is the people who belong in the specified category, in this case, number of success, in this case, teachers who believe that virtual reality has a positive effect in the classroom. X is 471, N is 500. Can she conclude that the proportion of teachers who believe it has a positive effect, it will have a positive effect, is greater than 90%? Okay. So my null hypothesis is P0 equal to 0.9. Alternate is P0. um, sorry, null hypothesis colon P equal to P0 equal to 90%, 0.9, and alternate is H1 colon P greater than 0.9. So my hypothesized value in the null hypothesis is 0.9. First, I need to check n times P0. N is 500. Value in the null hypothesis P0 is 0.9. So n times P0 is 500 times 0.9 is 450, and n times 1 minus P0 is 500 times, in parenthesis, 1 minus 0.9 is 50. Since these are both at least 10, the assumptions are satisfied. What are the assumptions? That is a simple random sample, and the sampling distribution of p hat is bell-shaped. Okay. The null hypothesis and alternate hypothesis are null hypothesis p equal to 0.9, alternate P greater than P, remember, is the population proportion, 0.9. We calculate the sample proportion, which is 471 divided by 500, which is 0.942. Now we have to compare this value of 0.942 to the value in the null hypothesis. So how will I calculate the Z using the calculator in one shot? We will do a left parenthesis to do the numerator. In the numerator, we subtract 0.9 from 0.942. Remember, 0.942 is the p hat. From that, we subtract the value in the null hypothesis, which is 0.9. Then put a right parenthesis to separate the numerator from the denominator. Then divided by. Remember, we have a square root. To get the square root in the denominator, after the division, we do second button on the top left, and then x square button, which is halfway down in the first column, that gives us the square root. Inside the square root, we are going to put P0, which is 0.9. Then left parenthesis, 1 minus 0.9. Remember, we are putting 0.9 because that's the value in the null hypothesis. After 1 minus 0.9, we put the right parenthesis. Then there is a horizontal line, that means divided by 500. N sample size is 500, and hit enter. So the test statistic is 3.13. Now from the direction of the alternate, P is greater than, the two slanted lines indicating greater than meets at an edge pointing to the right. So it's a right tail test. So greater than, so we need to find the area to the right of the test statistic under the standard normal curve. We can do second, worse, then 2. Since we want to find the area, we want to find the area to the right of the test statistic, 3.13. So my lower is 3.13. My upper is a very large number on the right, which is in the upper. I first type 1. Then I press the second button and the comma button, which is on top of the 7 button. Why do I need to do that? Because I need to get the small cap E. E stands for exponent. After E, I will type in 99. What does it mean? 1 followed by 99 zeros. So I'm going from 3.13 to the right, very far away number, 1E99. That is the area in the right tail. Mean is 0 because it's a standard normal curve. Sigma is 1. I do paste, enter, and enter. And p-value cannot be greater than 1 for sure. So it cannot be 8.74. Whenever we get a p-value greater than 1, we should look at the end. In this case, E minus 4. That means the first number, 8, in the p-value starts at the 4th place of the decimal. So the first 3 places after the decimal value, first 3 places are filled with 0. In other words, p-value is 0.000 and then 8. This is a very small number. 0.30 is an 8, almost equal to 0. So the p-value is very small. Now, we have not assumed a level of significance in this test. We can assume level of significance as 0.05. Normally, that is what it is. Level of significance is the maximum risk we are taking in rejecting H0 when it is true. In this case, our p-value, which is 0.0008, is smaller than the level of significance, which is 0.05. So decision is reject H0. If we reject H0, then we state at alpha equal to 0.05, there is enough evidence to support the alternate, which is P greater than 0.9. Okay, so they do the same thing here. Okay, so we can do the same thing without using the formula by pressing stat, then highlight test. Highlight test means move the cursor in the top row to test. So stat, then highlight test on the top row, much like what is shown in the first diagram on the top right corner. Then we scroll down to one prob Z test and hit enter. Okay, P0, our P0 is 0.9, value in the null hypothesis. What is our X value? X value is, we can go back over here, X value is the number of success, which is 471. What is my N value? Sample size is 500. And my alternate is greater than P0, greater than value in the null hypothesis. So I bring the cursor on greater than P0 and go down to calculate and hit enter. Again, I get the same test statistics, 3.13, and the p-value is 0.0008, which is less than alpha equal to 0.05. So reject H0 decision and conclusion at alpha equal to 0.05. There is enough evidence to support the alternate that P greater than 0.9. Okay. How to do it with... Okay, let's do this. The Pew Research Center reported that only 15% of 18 to 24-year-olds read a daily newspaper. The publisher of a local newspaper wants to know whether the percentage newspaper readers among students at a nearby large university differs from the percentage among 18 to 24-year-olds in the general. Differs from. This is a point to note because it does not say whether it is greater than or less than. She surveys a simple random sample, n is 200 students at the university, and finds that 40 of them, or 20%, read a newspaper each day. Okay, 40 of them, or 20%. 40 is the number of success. Here, success is to read a newspaper. 40 is the number of success, or x out of n 200. Can she conclude that the proportion of students who read a daily newspaper differs from 0.15? So we notice two numbers, one a small number, 40, another a large number, 200. It has to be a proportion test. So we go to stat, highlight test on the top row, then scroll down to number 5, which is one prop z test. And P0 is the value in the null hypothesis. Great differs from 0.15, so P0 value is 0.15. X is the number of success, which is the small number, 40. N is sample size, which is 200. And our alternate is not equal to P0. Okay. And then we go down to calculate and hit enter. So our test statistic is 1.980. This is a two-tailed test. The p-value, that is the probability value of getting a test statistic, at least as extreme as z equal to 1.98, is 0.0476. Compare that with alpha equal to 0.05. 0.0476, the p is less than alpha 0.05. Decision reject H0. Conclusion at alpha equal to 0.05. There is enough evidence to support the alternate H1, which is P not equal to 0.15. The one thing we did not do, we should have done, is n times P0. N is 200, and my P0 value is 0.15. So 200 times 0.15 is 30. That has to be greater or equal to 10. And then 200 times, in left parenthesis, 1 minus 0.15. Inside the parenthesis, press the right parenthesis after that, is 170. Both 30 and 170 are greater equal to 10. We need to meet these conditions because these two conditions make sure that the sampling distribution of P hat is bell-shaped. Okay. So we can go over the critical value method. Basically, we will use an alpha value, and then if it is a left tail test, alpha value is the area to the left of the critical value. If it is a right tail test, an alpha value, remember alpha is the level of significance. If it's a right tail test, alpha value is the value to the right of the critical value. So we need to, suppose your alpha is 0.05, then what is the critical value? I'm talking about the diagram in the center. So alpha is 0.05. We need to find the critical value Z alpha. If the area in the right tail is 0.05, then area to the left of that critical value, the area that is not highlighted, is 1 minus the area in the right tail is 0.05. So we do second verse, and then since we know the area to the left of the critical value, we do 3 in norm. Area we put is 1 minus 0.05, which is 0.95. Mean is 0. Standard deviation is 1. Pest, enter, and enter. The critical value in that case is 1.644. Why do we need that critical value? So Z alpha is 1.644 for a right tail test with alpha equal to 0.05. Remember, I did not plug in 0.05, I plugged in 1 minus 0.05, 0.95 as the area to find the critical value, because I always deal with area in the left. Okay. So I will calculate a test statistic using the formula at the top of the slide. If my test statistic is such that it is greater than the critical value of 1.645, then I will reject the null hypothesis. Okay, so let's see this problem. A nationwide survey of working adults indicates that only 50% of them are satisfied with their jobs. The president of a large company believes that more than 50% of employees at his company are satisfied. He surveys a random sample of 100 employees, and 54 of them report that they are satisfied with their jobs. Okay, can he conclude that more than 50% of his employees are satisfied with their jobs? Use alpha equal to 0.05. First, we will check out n times p0. The value in the null hypothesis is p0, which in this case is 0.5. N, my large number, is the sample size, is 100. So 100 times 0.5 is 50, that's greater than 10. And n times 1 minus p0 is 100 multiplied by 1 minus 0.5 is also 50. So both n times p0 and n times 1 minus p0 is greater or equal to 10. Hence, we can assume the sampling distribution of p hat is bell-shaped. Okay, now we have to do the test with the critical value method. It's a right tail test because the person wants to conclude that more than. So the null hypothesis is H0 colon P equal to 0.5. Alternate is H1 colon P greater than 0.5. So let's calculate the test statistic. And you know the critical value for alpha equal to 0.05, we already did it, is 1.645. So let's calculate. So we are going to first calculate the sample proportion p hat, which is number of successes divided by 100. 54 divided by 100 is 0.54. So in order to calculate the test statistic in one shot using the calculator, is first we put the left parenthesis. The idea in starting the calculation with the left statistic is to separate the numerator of z from the denominator. In the numerator, we have 0.54 minus the value in the null hypothesis, which is 0.5. Then put the right parenthesis. This will separate the numerator from the denominator. Then divided by, in the denominator, we have a square root. So second x square gives me a square root. Inside the square root, I have p0, which is 0.5. Then left parenthesis 1 minus 0.5, because p0 is 0.5, and then divided by sample size of 100. So my test statistic is 0.8. Notice my critical value Z alpha is 1.645, which we determined before, with the area in the tail 0.05, right tail. Area to the left of it is 0.95. Critical value is 1.645. Now this test statistic is less than the critical value. Therefore, we do not reject the null hypothesis, and we conclude that alpha equal to 0.05. There is not enough evidence to support the alternate. Okay. If we wanted to do it by stat test, then we will do stat button, then highlight test on the top row, scroll down to number 5, which is one prob z test. My P0, remember in this problem, P0 I'm comparing to 0.5, value in the null hypothesis. My X number of successes is 54. My sample size N is 100. My alternate is greater than P0. So bring it on greater than P0, the cursor, and hit it so that it's flashing on greater than P0. And we go down to calculate. Test statistic Z is 0.8. That means the value of 0.54 is located 0.8 standard deviation above the hypothesized value, which is 0.5. P-value is 0.2118 greater than alpha equal to 0.05. Therefore, decision do not reject H0. Conclusion at alpha equal to 0.05, there is not enough evidence to support the alternate that P is greater than 0.5. Okay, a Gallup poll of sampled 1,000 adults in the United States. These people, out of these people, 770 said they enjoyed situations in which they competed with other people. Can you conclude that less than 80% of US adults like to compete? Use the significance level alpha is 0.05. This is a left tail test because you want to conclude less than 80%. So your alternate hypothesis H1 colon P less than 0.8, null hypothesis H0 colon P equal to 0.8. Okay. So our level of significance is 0.05. It's a left tail test. Area in the left tail is 0.05. So we go second, verse 3. Area now is 0.05, mean is 0, standard deviation is 1, paste and enter twice. The critical value is minus 1.645. What does it mean? If the value of the test statistic is less than minus 1.645 or more negative than minus 1.645, then we will reject the null hypothesis. Okay. The first thing we want to check n times P0. Remember P0 is 0.8. So we will do 1000 n times P0 is 0.8. It's 800 greater equal to 10. Then we will do 1000 left parenthesis 1 minus 0.8 right parenthesis and hit enter 200. So both n times P0 and n times 1 minus P0 greater equal to 10. Again, I'm stressing the significance of calculating n times P0 and n times 1 minus P0 is to make sure that the sampling distribution of P hat or probability distribution of P hat is bell-shaped. Okay, so now we will calculate the test statistic, which is a comparison between the sample proportion and the hypothesized value in the null hypothesis divided by standard deviation of the sampling distribution of P hat. So first we need to calculate P hat, which is 770 divided by 1000 is 0.77. Okay, so let's calculate the numerator of the test statistic. So first I put a left parenthesis, press the left parenthesis button, then 0.77, that is the P hat sample proportion, minus my value in the null hypothesis is 0.8, right parenthesis divided by second x square gives me the square root, inside the square root 0.8, then left parenthesis 1 minus 0.8, right parenthesis divided by sample size of 1000. Okay, remember the new denominator is to be calculated assuming the value in the null hypothesis, which in this case is 0.8. So my test statistic, again, left parenthesis 0.77 minus 0.8, right parenthesis in the numerator divided by second x square gives me the square root, inside the square root P0 0.8, left parenthesis 1 minus P0 1 minus 0.8, right parenthesis divided by my sample size of 1000. Okay, and hit enter. And the the test statistic is minus 2.37. So minus 2.37 is farther away from 0 on the left than minus 1.645. In other words, the test statistic of minus 2.717 falls in the rejection region. So the decision is to reject H0 conclusion at alpha equal to 0.05. There is enough evidence to support, since we have rejected the null hypothesis, there is enough evidence to support the alternate that H1 P less than 0.8. Okay. How could we have done it in the calculator? Stat test. One prob Z test is 5. P0 we are comparing to 0.8. Our X success, number of success is 770. Our sample size is 1000. Our alternate is less than P0. So bring it on less than P0 and hit. And calculate. So we'll calculate the test statistic, which is minus 2.37. We'll look at the probability of getting a test statistic at least as extreme or more extreme than minus 2.37 is 0.0088, which is less than alpha equal to 0.05. Decision reject H0. Conclusion at alpha equal to 0.05. There is enough evidence to support the alternate H1 colon P less than 0.8. Okay. So that is the end of this lecture on hypothesis test for proportions. I have also worked out other problems which I'll provide link, and please if you like this video, give me a thumbs up. I really appreciate that. If you want to communicate with me, please send a note or write a note and I'll get back to you as soon as possible. If you like this video, again, please give me a thumbs up. If you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button, and please do not forget to click on the bell which tells you every time I upload a new video. Again, please do not forget to watch me tomorrow when I'll be back with something more interesting. Thanks for watching. Take care. Have a nice day. See you.